In this tutorial, we are going to talk about using the VR event system in SimLab Composer to create a training experience. Our goal in this training is to replace the old bearing inside the motor with a new one. To begin, you need to switch the workbench to virtual reality, then click on Start Position. The starting position will determine the initial location of the user at the beginning of the VR experience. First, we need to capture the scene states for all the interactive parts in the motor to store their current position, so that after they have been moved, we can still place them back in their original position. From the Scene States menu, select Capture. Make sure you disable all the attributes except for the transformation attribute. The objects that we need to capture scene states for are the 4 bolts holding the cover and the cover itself. Select the first bolt and click on Capture from Selection. Now if you go to the Scene States tab, you will find a new scene state named Scene 1. Click on it and rename it to Bolt 1. Select the second bolt and click on Capture from Selection, and rename its scene state to Bolt 2. Create scene states for the remaining bolts and for the cover. An additional part that we need to capture a scene state for is the new bearing. First, we need to place it inside the motor, as if it was installed replacing the old bearing. Then we are going to click on Capture from Selection. Now place the new bearing back on the table. As you can see now, whenever we apply one of the stored scene states, the corresponding object will return to its original position, which will prove helpful during the training. The next thing we need to do is to create an animation of the Allen T-handle unscrewing the bolts. Place the handle on the first bolt. Go to the Animation tab and set the current frame to frame 30. Then move the T-handle along with the screw out of the cover and rotate them counterclockwise. Now if you play the animation, you will see the Allen grip unscrewing the bolt. Select the keyframes and click on Create Animation Sequence. And name the sequence Bolt 1 Animation. Move the handle to the second bolt and create an animation sequence for unscrewing the second bolt. Follow the same steps to create an animation sequence for the remaining bolts. Now that we have created all the animation sequences required for the handle, we can return it back to its position. With the handle selected, go to the Actions menu and select Make Grabbable. Setting an object to be grabbable would allow the user to hold it and change its position and rotation during the VR experience. Now that we have prepared the scene, we can now start making the events that would control the VR training. From the Actions menu, select VR Events. The upper part of the VR Events window lists all the events created in the scene. The second part determines the type of the event, and in the bottom section you can determine the response for each event. The first event we need to create is, upon the T-handle touching the bolt, it will play the animation sequence of the bolt unscrewing. Set the event type to When Object Enters Object. Now select the T-handle and set it as the moving node. Then select the first bolt and set it as the area node. As for the response, set it to Play Animation Sequence, and select the Bolt 1 animation as the animation sequence. The event that we have now is, once the handle enters Bolt 1, play the Bolt 1 animation. From the View menu, select Desktop Mode to test out the scene. Press Escape on your keyboard to go back to SimLab Composer and open the VR Events window. What we need to do next is to create events to play the animation for the 3 remaining bolts. You can copy the recently created event and just change the area node since the moving node is the T-handle for all the bolts, and change the animation sequence for each bolt. Now quickly make sure that you have 4 events each playing an animation sequence for the bolt once the T-handle enters the bolt. Now that each event is playing an animation for each bolt being unscrewed, we also need to set the bolts to be grabbable after they are loosened. Select an event and add an additional response and set its type to Change Grabbable State, and set the same bolt that has its animation sequence playing to be the grabbable bolt. In each event, add a Set Grabbable State response for each corresponding bolt, and make sure you set the grabbable state to On. Once you have added responses to all the created events, run the desktop mode. As you can see, once we unscrew a bolt, it becomes grabbable as planned in the VR Events window. The next step in the training is to remove the cover since the bolts are removed. And since the user can remove the bolts in any order he wishes, we are going to have to use variables. Add an event and set its type to Object Exit Object. Set bolt 1 as the moving node and the cover as the area node. As for the response, set it to Change Variable Value. Click on the plus icon to add a variable, or you can access the Variable Manager from the top left corner of the Events window to add and edit variables. Name the first variable to bolt 1 and set its initial value to tight. In the response section in the event, set the value to loose. What we have created is an event that would change the value of the variable bolt1 from tight to loose once the bolt exits the cover. Duplicate the event and set the moving node to be the second bolt. Open the Variables Manager and create a new variable named bolt2 and set its initial value to tight. Let's create two more variables for bolt 3 and 4 with the initial values set to tight. Duplicate the event two more times and set the two remaining bolts as the moving nodes. Set the variable's value for each bolt to loose. Now we have four variables that will change their values from tight to loose once their corresponding bolt leaves the cover. The next event that we need to create is to set the cover to a grabbable object once all variable values are set to loose. Create an event and set its condition to Variable Condition Changed and type in bolt1 quote loose quote ampersand bolt2 quote loose quote ampersand bolt3 quote loose quote ampersand bolt4 quote loose quote. And as for the response for this condition, set it to change grabbable state. Run the desktop mode to verify the events we have created. Since we are using variables to determine the state of the bolts, it doesn't matter in which order we are removing them. Once the last bolt has been removed, the cover will turn into a grabbable object right away. Add another event and set its type to object-exited-object. Set the moving node to be the cover and the rod inside it to be the area node. Set the response to change to grabbable state. And set its object to the worn-out bearing inside the motor. Now that we have created an event to remove the old bearing, we need to place the new bearing instead. Add an event and set its type to object-exited-object. Set the old bearing as the moving node and the rod as the area node. And set the response to change grabbable state of the new bearing to on. Create a new event and set its type to object-entered-object, and set the moving node to be the new bearing and the area node to be the rod. And the response to be the scene state that we created earlier, where the new bearing is positioned inside the electric motor. Now we need to reassemble the cover, so create an event and set its type to object-entered-object. Set the moving node to be the cover, and set the area node to be the rod or the chassis of the motor. As for the response, set it to scene state and select the cover scene state where the cover is positioned the same as before taking it off. You also have the option to remove grabbable state from objects once you correctly place them back. So you can add a response in this event, for example, to set the grabbable state of the cover to off once you dock it on the motor. Next is putting the bolts back in their places. Create an event and set its type to object-entered-object, and set the moving node to be bolt 1, and the area node to be the cover. And set the response to apply scene state and choose the bolt 1 scene state. And add another response to change the variable for bolt 1. And set the variable value to done. Follow the same steps to create events for all 4 bolts being placed back inside the cover of the motor. Now that 4 bolts have events to return them to their original position after changing the bearing, we need to notify the user that he has completed the training. Let's use scene states to display a message on the screen ahead of the user. Click on the screen and add an image as its texture. And from the Scene States menu, select Capture. Make sure you enable the material attribute only in the Scene State panel and click Capture from Selection. Now remove the added texture from the screen material as if it was turned off. Go back to the VR event system and add an event and set its type to Variable Condition Changed. And type in the condition bolt 1 == done ampersand bolt 2 == done ampersand bolt 3 == done and bolt 4 == done. And set the response to apply the TV screen scene state and optionally to disable the grabbable state of the bolts. Run the desktop mode or the VR mode to view the result. The VR event system in SimLab Composer gives unprecedented potentials to your VR training experience. You can now create various types of events that control the behavior in your scene with simplicity and ease.